Okay, so in these trig identities simplification, we're going to use a bunch of algebra properties. Okay, all of the stuff we learned in elementary school about numbers and fractions and adding things can be applied to these trig things. Okay, they just have really strange words because they're trig rather than just x's and y's. Okay, but the properties are the exact same. Like here, in essence, I basically have a fraction plus a fraction. Okay, we talked about adding fractions in elementary school, and then maybe in junior high, in order to add fractions, they have to have the same denominators. Okay, maybe it was Algebra 1 that we actually talked about how to deal with that. Okay, and we deal with that by making the denominators the same. So you multiply by the least common denominator. So if I want them to be the same, this one needs to have a 1 minus cos involved. So I multiply by 1 minus cos on top and bottom. Okay, which is basically 1, right? Anything divided by itself is 1, so I'm not really changing this. And this one I'm multiplying by 1 plus cos because that's what the other denominator happens to be. Okay, so I'm using this algebra strategy to add fractions by having the same denominators. Okay, now the multiplication here is pretty simple because I'm just timesing it by 1. So this gives me a 1 minus cosine over, let's do some distribution. There's a 1, there's a positive cosine, there's a negative cosine. Oh, those cancel out. And there's a negative cosine squared. So that is what my denominator becomes when I do all of that distribution. Over here, oh, I'm just multiplying by 1 again, so 1 plus cos on top. And I will once again distribute into all these things, and look what I get, 1 minus cosine squared. Okay, which is exactly what you're supposed to get when you multiply by the least common denominator, is a common denominator. So because these things are common denominators, right, they have the same denominator, I can add the numerators. So let's go ahead and do that. Let's add these things together. 1 plus 1, well, that's 2. Negative cos plus cos, well, that's gone. And on the bottom, I just have 1 minus the cosine squared. Okay, so now it's time to do some trig substitution. Hopefully you know that 1 minus the cosine squared is also known as sine squared. Hopefully you know that. Okay, that's a trig identity. Let me write it down over here in case you didn't. The cosine squared plus the sine squared equals 1. That's the main basic Pythagorean identity. Okay, so if I bring the cosine over to this side, I get sine squared equals 1 minus cosine squared. So I'm able to replace 1 minus cosine squared with sine squared. Okay, now this is still looking kind of fishy, but I remember another reciprocal that the the cosecant is 1 over the sine. Right? So that means the cosecant squared is 1 over the sine squared. Now, this isn't 1 over, it's rather 2 over. So I'm going to, in the end, have 2 cosecant squareds rather than just 1 cosecant squared. Okay, and that is as simple as this trig identity is going to become. Okay, so we employ the strategy of multiplying by the reciprocals, or not reciprocals, but multiplying by the other one's denominator so that we can actually add these two fractions together. Okay, and then we do some trig stuff down there, and we get a nice simple answer. Okay, probably not so nice on this one, but let's do it anyway. So once again, in essence, I have a number minus a fraction. Okay, and I can't actually subtract numbers from fractions unless they're both fractions. So I'm going to make the thing on the left into a fraction with the same denominator. So I'm multiplying this by tan over tan. Okay, so that changes the left side to tan squared on top over just tangent on bottom minus secant squared over tan. Okay, so now that I have two fractions with the same denominators, I can add the numerators. In other words, in this case, subtract the numerators, because it's a minus problem, over one single denominator. Okay? Now, there's a Pythagorean identity that says if I have the tangent squared plus 1 value, that's the same as having the secant squared. Okay, that is one of your trig identities. Now, with a little manipulation, I can bring the secant over here and the 1 over there so that I have tan squared minus secant squared equals -1. Okay, now that's a little manipulation of that trig identity, that Pythagorean one. So instead of tan squared minus secant squared, I can have a -1. With the same denominator as before, -1 over the tangent. Okay, now I recognize 1 over tan as being the same or the reciprocal of the cotangent, which means -1 over tan must be the negative of the cotangent. Okay, so we took this squared thing on top of a subtraction of a number and a fraction and whittled it all the way down to a single trig word, which is much simpler than what we started with.